Good day everyone. Today, I will present a basic tutorial on how to model, analyze, and design a structure using STAAD Pro. First, we open STAAD Pro and create a new project. In this step, we input the project name, choose the structure type, and select the unit system such as metric or English. The next step is creating the geometry of the structure. Geometry refers to the physical shape and arrangement of the structural members. In STAAD Pro, we create nodes first. Nodes are points where members connect together. After placing the nodes, we connect them to create beams and columns. These members form the structural framework or skeleton of the building. The software provides different methods for creating geometry. While creating members or drawing structural elements in STAAD Pro, press and hold the Control key to prevent the rubber line from automatically following or snapping to the cursor. This allows better control and more accurate placement of nodes and members during the modeling process. It is especially useful when editing complex structural layouts or avoiding unwanted connection between members. At this stage, proper geometry creation is very important because incorrect member connections may cause instability during analysis. After creating the geometry, the next step is assigning members property. Member properties include the shape, dimensions, and size of structural members such as beams and columns. Examples include wide flange sections, channel sections, rectangular concrete sections, circular sections. The selected section properties affect strength, stiffness, deflection, structural stability. Larger sections usually provide greater strength and stiffness, while smaller sections may reduce construction cost but may not safely resist the applied loads. Proper selection of member properties is essential for a safe and economical structural design. Next, we define the material properties of the structure. The most common materials used in STAAD Pro are structural steel, reinforced concrete, aluminum, timber. Each material has different mechanical properties such as modulus of elasticity, density, yield strength, Poisson's ratio. These materials' property affect how the structure behaves under loading conditions. For example, steel has high tensile strength and ductility, while concrete has high compressive strength, while timber is lighter but less stiff compared to steel. STAAD Pro After assigning member properties and materials, the next important step in STAAD Pro is defining the specifications. Specifications are additional instructions assigned to structural members to control their behavior during analysis and design. These specifications help simulate real structure conditions and improve the accuracy of the model. Without proper specifications, the analysis results may become unrealistic because the software may assume incorrect member behavior. The purpose of specifications are used to define support behavior, assign releases, set design parameters, control member behavior, simulate actual structural conditions. These settings help engineers create more realistic and accurate structural models. One of the most common specifications in the member releases are used to remove moment resistance at the ends of members. For example, a pinned connection does not resist bending moment. A fixed connection resists bending moment. Instead, we can release moment about local axis, shear force, and torsion. This is important in modeling trusses and simple beam connections. Tension-only specification allows a member to carry tensile force only. If compression occurs, the member becomes inactive during analysis. Examples include cable structures, steel bracing, suspension systems. This specification improves the accuracy of tension member behavior. The next step is assigning supports. Supports represent how the structure is connected to the ground or foundation. The common support conditions are fixed support, pinned support, roller support. A fixed support restrains both movement and rotation, while a pinned support allows rotation but prevents translation. Support conditions are very important because they directly affect structural stability. Also, their reaction forces, the deflection behavior, and internal force distribution. The next step is assigning supports. Supports represent how the structure is connected to the ground or foundation. The common support conditions are fixed support, pinned roller support. A fixed support restrains both movement and rotation, while a pinned support allows rotation but prevents translation. Support conditions are very important because they directly affect structural stability, reaction forces, deflection behavior, internal force distribution. Incorrect support assignment may produce unrealistic analysis results. Such as dead load may include sulfate and permanent fixtures. Live load includes occupants, furniture, and movable loads. After creating the load case, we can assign the self-weight of the structure to do this. Click Add Self-Weight, choose the direction, usually Y direction downward, enter the factor as -1, or StatPro automatically calculates the weight of structural members based on material density and section size. The example for that is the self-weight command automatically applies the weight of the beams and columns without manually calculating each member load. The next step is assigning member loads. Maybe it will be uniform loads, concentrated loads, or trapezoidal loads. To apply a member load, select the beam member. Click Add Member Load. Choose the load type. Enter the load magnitude and direction, and assign the load. For assigning, if you will use uniformly distributed load, select uniform force, enter the load value, choose the direction. Example, a floor beam may carry a uniformly distributed load from slab weight. In this example, I applied a uniformly distributed load along the beam to simulate floor loading. To apply a point load, select concentrated force, enter the load magnitude, specify the location along the beam. Point loads are commonly used for machinery loads, column reactions, equipment loads, and also we should consider the floor loads. So define the floor area, enter the load intensity, assign the floor load, and the software automatically distributes the floor load to the supporting beams. Before running the analysis, we must verify the model carefully. StatPro provides tools for checking duplicate nodes, unconnected members, instability problems, overlapping members, geometry errors. This step helps ensure that the structure behaves properly during analysis. A properly connected model reduces analysis errors and improves accuracy. Once the model is complete, we run the structural analysis during analysis, and after analysis, we can now view the structural results. StatPro displays graphical results such as shear force diagram, bending moment diagram, and etc. Thank you, and that concludes my presentation.